Hello, my dear lovely Algebra 2 students. Just wanted to say hello before we get into the lesson. Let me take myself out of here. Sorry, that always happens when I do that. Anyway, bye. You're not going to see my face anymore. So, this lesson is 1.7. We're going to go over exponential notation using exponents. So, I'm just wrote a number on here, 81, and it can be represented different ways, and I'm going to show you one way, a standard form, like saying 8 times 10 plus 1. We know that that equals 81. Next, here is an exponential way of showing 81. If I said 3 to the 4th power, because we know that 3 times 3 times 3 times 3 equals 81. So down here is a cute little graphic I made for you to show you that any number a raised to the nth power, the a is called the base and the n is the exponent. Isn't it cute? Don't you like how I'm putting these things in here now? I like it. So, I told you this week would be better. Hopefully it is. So, this can, my 3 to the 4th power, you can say it 3 to the 4th power is a power of 3 because it can be written as a product where all of the factors are 3. It's just a fancy way to say what we know, that 81 equals 3 to the 4th, which equals 3 times 3 times 3 times 3. That's all that means. So don't get all in a mess over all this crazy language. Jessie, I know you're like me. So shout out to Jessie, everybody. We love her because we get tied down in the little things, and that's really all that this is saying. All right, so I wanted to show you a little rule here because we know numbers like this, 3 to the 4th power, what that means. I wanted to show you that any number to the 1st power is itself because you're not multiplying it by anything else, right? It's just that number. Any number to the 0 power is 1, and I thought I'd put in a little example here to show you why, just because some people like to ask that. And I gave the example that like 3 to the 4th over 3 to the 4th equals 1. That would cancel, right, and become 1. And here's the law of exponents, but if I wrote it all out, I could turn it and say that it's really 3 to the 4 take away 4 because I had 3 4s on the top, right? And I had 3 4s, sorry, not 3 4s. I had 4 3s on the top and 4 3s on the bottom. And 4 take away 4 is 0. So 3 to the 0 power equals 1. So anything to the 0 power is going to be 1. It's going to work itself out just like this one did. And then I hope that didn't confuse you. If it did, don't stress out. Just remember, anything to the 0 power is 1. Now, I'm not going to go into it, but you can't have this base number equal to 0. It just doesn't work. And just trust me on this one. Just trust me on that one. Can you say that? All right, so now we've been talking about whole numbers. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7. But what about integers? Remember, integers include those negative numbers. So if you have a number to the negative power, it's the same as saying 1 over the number to the non-negative power. So b to the negative n is the same as saying 1 over b to the n. As long as this little rule is in place and b does not equal 0, we can't have that. Just remember that. So in essence, b, any number to the nth power and any number to the opposite nth power, those are reciprocals. Isn't that nice? So let me show you why that works out the way it does. So I put this little chart in for you, and I filled it out a little bit right now. And I've got 10 to the 3rd. If you work that out, that's 1,000. 10 to the 2nd, that's 100. 10 to the first, where I said that's going to be 10, and anything to the 0 power is 1. If you notice a pattern here, you're noticing that each time we decrease the power, we're really dividing it by 10. Do you see that? 1,000 divided by 10 is 100. We're decreasing the powers. 10 divided by 10 is 1. So what we're doing is dividing by 10. So if we keep that up, then 1 divided by 10 is 1/10. So 10 to the negative 1 power, let me get my red color over here, is 1 over 10, right? Which you could say 10 to the first if you wanted to see it that way. And then 10 to the negative 2 power is 1 over 10 squared, because that's divided by 10 again. And then 10 to the negative 3 power is 1 over 10 cubed. So if you look at it this way, you're just putting it in the denominator and making the power positive instead of negative. But that's why it works out like that when you have integer exponents, when you have exponents that are negative. So if we go down here and work out a couple examples, and then we'll do some practice tomorrow in class. First, I wrote -2 to the negative 3rd power. And so since that's an integer up there, -3, let's do this. Let's call this 1 over -2. And now we're just going to make that power positive to the 3rd. And if we work that out, that's going to be -8, right? So it's really -1/8. That's how that works out. That's what this is equal to. All right, here's one more example, and then we will try some more at home. And you're free to look at more examples in your book, because I'm taking this from your book. This is page 36. So here we have our negative integer. So we're going to rewrite this as being 1 over 3x squared. And I could work this out, and that ends up being 1. So 3 squared is 9, and x squared is, well, x squared. All right, I hope this makes a little sense. If it doesn't, re-watch it, ask me tomorrow, write it in your questions, or take a look at some more of the examples in your book, and I will talk to you tomorrow. Goodbye.